Hello guys, welcome back to a new video. So let me switch the screen here. So we already solved this much of problem. Yesterday we solved Sudoku problem, valid Sudoku problem, and today so I already opened this problem and it's not available to free users. It's only available to premium users, so we can't solve it. Let's skip this and solve this. So I already opened this. Let me just read the question first. So we have to find the longest consecutive sequence. Consecutive means like one other after other, one after other. So that doesn't mean like a consecutive sequence in this. Given an unsorted array of nums, return the length of the longest consecutive element sequence. You must write the algorithm O of n. Yeah. So here some details are not there for this question. So we have to understand from this example, like the non consecutive longest consecutive sequence here means like 1 2 3 4. So numbers which are consecutive of each others in this given array, we have to find the length of the longest consecutive series or numbers inside this nums array. So here it is given like 1 2 3 4 which are present, but they are not in the order, so we have to find the order and the length. Basically we have to return the length of that order. Yeah, here there are two repetition you can see, but it is only counted as one. So 0 1 2 3 4 5 6 7 8, so that all 9 total. These are 10, but not 9 because repetition is not allowed, not counted. Basically it is not given here, we have to observe from these examples. Yeah, so it is 10 to the power 5. So the n square problem will give time error, like time limit error. So that's why the n square problem will not work. Also it is told us that we can't use we have only do it in O of n, otherwise we just sorted it and just counted the non-repeating increasing values. Yes, so we have counted that. That will also work. That will work in n log n though. So yeah, so the approach is quite simple. Like let me just copy this. What we can do is we can build a map of this like this. Every value against like for example this, we will store -1. Initially we will store -1 against each value, and the map will have the only unique values. So like this 200 we have -1, and then 1 -1, and then 3 -1, and then 2 -1. Then what we can do is we can just again iterate over this array, and we will check if the current value -1 value present in this or not. So we can directly check from the map. So there can be two cases. So one case can be like we will check the next value, not the previous value. So we can do in both ways. Like for this example we are going to do plus, well, we can check plus value. So 101 is not present here, so that will not be counted, and the value in this map against this 100 will be set as 1. Then we will go to 4. We will check 4 plus 1 5. 5 is not present here, so it is going to be 1 here. So the longest sequence starting from this will be 1. Now then 201 is not present, so it will be 1 also. Then the 1. So the 1 plus 1 is 2. 2 is present. Then we will go to 3, and 3 is also present. Then we will go to 4. 4 is also present, but the values against is already given, so we will return from here, and we will count. We will just add up all the values till now. We will maintain a count, and then we will save it to this. So the count will be for 1 will be like 4. Similarly we will do for 3. 3 plus 1 is 4, and 4 have already 1, so 1 plus 1 2. So longest sequence, increasing sequence starting from 3 in this array will be of length 2, which is 3 and 4. Similarly for 2 it will be of length 3, and the sequence will be like 2, 3 and 4. So yeah, and while doing this we will have a max variable which will count all, which will have the max of all these values while we calculate these values. So the max of all these values is 4, so the answer will be 4. So this is the approach we are going to use it here. So let me check. Yes, it is recording. Yeah, so this is the approach. For that we need an unordered map of int and int. Let's say it m, and we will pre-populate as I told you with -1. So for num in, so we'll reference this num and nums. We will have our m nums against, we will store -1. Then we will reiterate over this, and also we will, as I told you, maintain a variable that will be the answer. We will return this variable, and yeah, so now for every ampersand num in nums, we can't change this value because we need to set the value against this, so we store it in a temporary variable called current, and now we will increase this value. So as I told you, we will increase and check for it. So how we are going to check? So it will be like this: while m dot find current plus 1 not equals to m dot end. That will check if, like for example, when we are at 100 plus 1 101, so current will be 100 plus 1 101 will be present in map or not. So while it is in present, we will calculate like this. We also here have our count, which will be initially 0, and then while there is a value inside this, there will be two conditions. If it is, if m of current plus 1 equals to -1, else the other case, else we will just simply increase our count as I told you, and also the current value by 1. Otherwise what we will do is we will set our count as the m, increase our count, the current value percent interval, current plus 1 value. Yes, current plus 1 value. Yes, and then once everything is done here, the while loop ends once we don't find the value. That will be the last value for this sequence. Then we will simply set our value so that it can be used by other iteration. So we have to set it against the num. So that's why I told you we can't change this. We just store in a temporary because we are changing it here. As you can see, current plus plus. We have to store the count, and we have to update our max as the max of count and this. Yeah, let's check if there is a problem or not. Okay, I guess we are doing something wrong here. We are increasing. Yeah, we should break here. Once we have find the value, then we have to break a non-negative value that is already, yeah. Also, I think we are doing something wrong here. I guess this should be 1, because if there is no value, like for example this 101 is not present, so it should be 1, because at least 1 can be a sequence. The length of this smallest sequence can be 1, so yeah, that should be initiated with 1. And also this should not be not equals to -1. Yeah, this is working for this case. Let me submit it and check for other cases as well. Yeah, this is working. So let us check the time complexity here. So as you can see, we are running this for loop, that is the length of the nums and also this for loop length of the nums, and this while loop will, for every number, it will go once, because we are storing the value here, and once it is get to the length, then it will not run again. So that's why we already calculated, so it will be O of 1 approximately. It we will consider it this one because it will not be uh, as this much. For example, we will only like go through once on a path. Yeah, so that why it will be of 1 as compared to this n. And so overall time complexity will then be, let me write here, of n as required with the this condition. You must write the algorithm in O1, and also the space complexity will be uh, we are storing all these in map, so it will be also O of n. Yeah, so let me just check this. Yeah, so I have already created a playlist for this. You can go and check. And also, did you like, if you like the video, please click on like and also consider subscribing, and I will see you in the next video.